In section 1.7, we're going to talk about applications. It's an entire section of applications, which I know you don't enjoy, but we do need to get you over that anxiety some in terms of word problems and applications. So the first part of the lecture is designed to help you recognize that you can do these, to give you some helpful hints in the process of doing them, and also to help you classify them. So a lot of what I'm going to do in this part 1 is just read what's on that actual handout to you, but that's to slow you down and help you get over that anxiety. So when you do a word problem, what's the first thing you usually do? You usually panic, you roll your eyes, or you just plain quit and decide you're not going to do it because you're no good at it. So part of the reason is that word problems combine reading comprehension with algebra, and that's usually the issue. We're asking you to go from words into numbers and into an algebraic equation. So there are several steps that you can take to help you become more successful. And so these are what the steps I recommend are. So read the problem and then slow down and read the problem again, because the first time you read it, you really read it fast in the hopes that it'll get over quicker. It doesn't work that way. So read it again. As you read it, start to look at the different numbers that are given and think about those. Classify the problem. This is important in this first section 1.7 because there are 5 main types of word problems, and we'll go through those 5 types, but classify it because that'll help you decide on what approach to take. Write an equation, solve it. Look at the answer. Does the answer make sense? I mean, if you're solving for a dosage calculation and you end up needing 200 tablets, that does not make any sense. If you're solving for a distance between 2 cities and you end up with a negative distance, that does not make sense. So look at the answer. Don't just write it down. Don't forget to answer the original question, because sometimes it'll ask for what you designated as X, and sometimes it'll ask for the other variable that's floating around. And then don't forget units on the final answer. So when we classify these, we're going to classify them into 5 categories. The first one, category 1, and they're numbered just to help us talk about them. That's the only reason they're numbered. They're not really numbered in the real world, folks. So, but category 1 is what we're going to call interest problems. So I'm going to write them over here and then try to remember not to erase them. So these are interest rate problems. And the key words to look for are interest earned, investments, more than one interest rate is given. And we'll use a chart. And as we go to do an example, I'll write the chart on the board and we'll follow that chart. Category 2 is what we're going to call mixture problems. And you've seen these. You're combining some percent alcohol with another percent alcohol, with a third percent alcohol. You could also be mixing different types of coffees together. You could be mixing different types of mixed nuts together. The key is that you're taking 2 quantities and mixing them together to create a third quantity. Again, we'll use a chart to solve those because it helps us organize the information, which is always nice. The third type is what we call uniform motion. Uniform motion. And what those involve is a boat, a plane, a person, train, traveling, and you're dealing with usually rates, speeds, miles per hour, kilometers per hour, time, and distances. So the key words are a person, somebody traveling, objects catching or approaching each other, going with the stream, against the stream, going with the wind, against the wind. We need to remember there's a formula involved with that one, and that formula is that distance is equal to rate multiplied by time. And so that's a handy formula to use. And again, there's a chart, helps us organize the information. The next category is what your book calls a constant rate job application, which is a huge title. So instead, I'm just going to call them work problems. And the key here, more than anything else, is that you have 2 things that are accomplishing a job. You could be filling a bathtub with water, you could be painting a house, you could be printing paper, you could be passing out leaflets. The key here is the only unit mentioned is time. So it's completing a task. So as it says, the key to recognizing is the job is being done. There's a formula, and as we do one of those, we'll write the formula. But basically, you're going to do 1 over the first person's time plus 1 over the second person's time equals 1 over the time working together. And then finally, the 5th type or category we're going to see in this section is geometry kinds of problems. And for geometry, will involve areas, perimeters, might be the right triangle with the Pythagorean theorem. In general, you're going to draw a picture, label that picture, and then use a formula. So those are the 5 types that you're going to see. So let's just jump in and do one and see how we do. So the first one we're going to do, this is example 1. Example 1 says, Fran recently inherited $50,000. She can invest part in B-rated bonds at 15% per year and part in a certificate of deposit, which is also called the CD, paying 7% per year. She would like a return of $6,000 per year. How much should Fran invest in each to realize exactly that $6,000 in interest per year? So I look at that and recognize that this is an interest problem. It's our category 1. So we're going to use a chart. And the chart's going to help us organize the information. So our chart, and I'm going to abbreviate a little bit here. We're going to have A, which is the dollar amount that we're investing. Actually, you know what? Let me make sure I'm consistent in my notes. Yeah, amount. So it's a dollar amount. So amount, and that will be in dollars. The next column is rate, and that's really the percent that we're earning. And then the final column is the interest earned. But the interest earned is simply the amount multiplied by the percent by the rate. So in other words, to do this, we're going to put numbers here, we're going to put numbers here, and then to get to this column, we're simply going to multiply this column by this column. We have 2 investments. So we'll call one of them investment number 1. The other one's going to be investment number 2. And then we have a total for both the investments and the interest. So there's our chart. And again, it's just an effort to help us organize the information so that we can write an equation. So let's start putting the numbers in. We know that she's got $50,000 to invest. That's her total investment. That's going to go over here as the amount of money in the total. They then give me 2 different interest rates. One of them is 15%, so that's 0.15 as a decimal. The other interest rate is 7%. And those are the 2 investment rates or interest rates for the different investments. So yeah, one of these is the bonds, the B-rated bonds, the other one's the CDs. And does it really matter in what order we get those 2? It doesn't, but I like to put them in the order that they're given to us in the problem. The only other number in the entire problem is the 6,000. Well, the 6,000 is the total interest earned, the total interest earned. So that's going to go over here. Now I don't have another rate, so I'm just going to put a slash in there to indicate there's no number going into that spot. Okay, there's all the numbers from the problem. So we've now taken the problem, we've organized the information. Now we're going to write the equation. To do that, we need some variables. So I'm going to come in and let X be the amount of money we're putting into those B-rated bonds. So X is some amount of money, 10,000, 12,000, 15,000, 40,000, I don't know. Whatever is left over is going to get invested into those CDs. So the leftover chunk is going into the CDs. Well, I know I'm using X here. I have 50,000 altogether. So this amount is going to be that 50,000 minus X. In other words, if you put 10,000 here, you put 40,000 here. If I put 15,000 here, I'm going to put 35,000 here. And the way to get that is to take that total and subtract off what you've already used. Now we're going to come in and multiply across. That's what the chart is telling us to do. So the interest from the B-rated bonds is going to be 0.15 times the X. So that's this column times this column. We'll do the same thing in the next row. We're going to take the 0.07 and multiply it by the 50,000 minus X. Those guys boxed off. Okay. Now that we've done that, the chart's complete, and the chart's going to help us write our equation. And we're going to use this last column to write the equation. We're going to recognize the 2 investments together have to equal the 6,000. So literally, this is where our equation is going to come from. So we take the 0.15x plus the 0.07 times 50,000 minus X, and that's going to be equal to the 6,000 that we need to earn. This is a linear equation, so at this point we just need to distribute to get rid of those parentheses and solve that linear equation. So now we're down to the algebra. 0.07 times 50,000 is 35,000 or 3,500 minus 0.07x. Watch my zeros. That's equal to 6,000. We'll collect like terms, so 0.15 minus the 0.07 is going to be 0.08x plus the 3,500 is equal to 6,000. We're going to subtract that 3,500 over to this side. That's going to give us 0.08x is equal to 2,500. And then finally, we'll divide it out. And when we divide it out, we get 31,500. And that's X. So where are we in terms of it? Let's make sure we're answering the question. Well, X, according to the chart, was the amount that we're investing at the 15%. So as an answer, we're going to invest $31,500 at 15%. But I also need to know, because it wants to know how much we're investing in each of those investments, we need to know how much is going to get invested in the CDs. So to do that, we're going to take the 50,000 minus X to get that. So 50,000 minus the X we just found, the 31,500, is going to give us 28,500. And that's how much we're going to invest. So 28,500 at the 7%. So the nice thing about the chart is that when you're done and you've got a number, you can go back and look at the chart and figure out what the heck that number is. And then make sure you're answering